Welcome to CS 112, Lesson 14.3, Text. This is made for University of Idaho's CS 112 dual credit program. Alright, so today we're going to be making some kind of the part that a lot of people are always really interested in, that's text. While having stuff show up on the screen is really fun, a lot of people like to have something like written on a screen. Kind of more sense of power, if you will. So today we're going to start off with a warm-up. Today's warm-up is to run the following process code. This is the code. As always, whenever you're watching these videos, be sure to pause if you need more time. So the thing that you're going to need to do is you need to put this in, and when you put this in, you should get some kind of result. And what you need to do is you need to try to adjust the size of the screen, which isn't actually set, to make it fit the screen, or you can change your text size. You can try and figure out where that might be in order to fit the entire screens. Which adjustments did you do? And make sure you put that as a couple sentences on your teacher's website or learning system, such as Schoology. If you need more time, definitely pause and kind of finish figuring that out. We'll be referencing back to this a couple of times, but we're going to move on. So, like I said, we're going to be talking about text today. So here's a couple of examples of text that we're going to have kind of popping up. We're going to do our alphabets. We're going to have everything kind of spelled out for us. So in 14.2, we made some art pieces, really art pieces being we blended two pictures together. In previous lessons, we were actually able to make things pop up in our console, which is that little black bar at the bottom of our processing screen. But now we're going to make it pop up on the actual screen, on the actual canvas, which is kind of fun and exciting. So we already did this, and what wound up happening is that the text ran off to the right side of the screen. You either had to change the screen size or change the size of the text in order to make it work. Hopefully you found where that was, how to change the text size, because that's the name of it, is text size. So um, this should have been what you kind of got altogether. You should have gotten this once you fixed your screen. The song length is 26. The text width is 255. That should have printed in the console. Um, and your text width might have changed if you decide to change the size of your text. If you change that text size, you might have gotten a different number than that. And that's totally fine. It's expected, actually. Okay, so a couple things. We've used these before, and I don't know if we've really expressly talked about it. So print and println, and these are used to display text in the console. Println moves to the next line after printing, whereas print does not. It stays in the same spot. Uh, so in order to print text, it needs to be in quotes, and the reason for that is that if it's not in quotes, it thinks that it's a variable. And so it looks for a variable named that. When it can't find it, it can freak out or just could not do anything. To print the value of a variable, you just put the variable in there. Don't put it in quotes. So some examples of things that you could do. If you wanted to print Mary had a little lamb, it'll do that. Then it'll go to the next, then it'll go to the next line, and then, or if you wanted to, in this case, you can make a number and you print the number. You can print the string, and then it'll print that. And then this is an example of that for loop that we've used before. This is a pretty common use for for loops, is to use this I. Um, and then again, another version of that right down here. Uh, Text is much the same. And what it does is we tell it what text to display, how far from the left, how far from the top. Um, Telling it what size is actually done in a different location, which is kind of confusing to some people that it's not in the part of that part of the text. But if you kind of think of a word processor such as Microsoft Word, you set the size of it before you actually even start typing, and so it's actually a very common thing for you guys to do. So try the following. So we are going to go, let's do size 200, 200, and we're going to make a text, and it says Humpty Dumpty sat on a wall. Fun thing I just heard about this is at no point in time does it ever actually say that he is an egg. Yet everyone, whenever they hear Humpty Dumpty, think he's an egg. All right. So let's go ahead and push that play button. Hopefully you can read this. It might be a little dark or a little light, but it should say Humpty Dumpty sat on a wall. Um, and it's actually kind of purposeful that I made it so that, or so that we made it so that it started off white. So let's try and change it. Let's add some color. And so let's fill. Let's make it a color. Let's make it blue. 0, 0, 255. So if I run this, hey, we have Humpty Dumpty set it on a wall. Now, to also kind of let you in a little bit on the programming side of things, is the next phrase that we're going to do. It's kind of the stereotypical first thing that you have a computer do. It's pretty basic in terms of things to display, but it's kind of famous for what it is, and that is the hello world statement. Um, so go ahead and type in hello world, and you can have your first kind of like feeling of yes, we did this, because I mean this is kind of like the programmer thing to do is to make your program say hello world, and from there you just build. Okay, let's go back to it. Okay, so a couple things to look at in the warm up that potentially you had. So that string, that first thing that we had, that string. Um, so it's actually a variable. And it's a variable and it's a data type. So it says that song is it's a type of string, and a string is a whole bunch of letters that follow together. Um, and then later on, we actually assign what song is. In all reality, we could have put this song up top, and let me grab my laser pointer. We could have put this whole thing as a part of this if we wanted to, or we could have it down below, and that's totally fine. This is what's output to the screen. So we put the text, what this text is, then we put the text size, and what this actually does is this will show up as one thing, but this will make it bigger, and then it will fill, and then we have a text. And then we output to the console how long it was and all that type of stuff. Okay. Yeah. So characters. Characters are a piece of data such as AG9 dollar sign, and in processing, if we're using just a single character, we use a single quote. And char, I call it char, or it's like I guess this is like char, is the data type for individual characters. So if we go and look at processing, come on, there it is. Okay, if I say char letter, this makes a variable called letter. And if I say instead char letter equals n, then it sets n, or letter, to be n. And you need to use single quotes for characters. Um, each part actually has a corresponding value in the ASCII table. Uh, it's useful to know those, but at least for me, I don't expect you to memorize them. But it is helpful to know that there is a like kind of a chart that shows what everything looks like, or what everything is coded as, if you will. So here's the ASCII table. Um, Hopefully you've seen this before. If not, definitely kind of check it out. Take a little bit to kind of see how it works. Um, it's really helpful whenever you start working in like doing coding and stuff like that. Especially like these control characters are very well used in a lot of places. So let's try this. So let's make a char, and we're going to make it letter, and let's make it a capital A. Underneath that, for if an integer I that equals 0, if I is less than 26, I want I to increase and print the letter, then letter plus plus. This is similar to that I plus plus that we see up top. So what this does is this is actually going to increase it. Then we want to print ln and then do another character dot. Let's see what this does. So if I click the run button, it actually does it in the console because that's where that print happens. And so it goes A, B, C, D, F, G all the way through Z, then it gives a period. So all of those should have printed. If not, stop this, check it out, try and see where you did wrong, where you kind of got wrong. Okay. So kind of going back to what I was talking about for string. So string is used to store words and sentences. Um, we surround these with double quotes. The hard part with processing is that strings can't be changed. You can create new strings, but you can't go in and change something. So, for example, if we put Mirror Lake, we can't have processing actually go in and change the word in there. So we can't like take out the R's out of Mirror Lake. It just kind of exists as that. So let's go ahead and go and try this kind of little example. So let's make it show this. So if I have a string and I'm going to call it M, and that's going to be, and in quotes I do mirror, and then I have another string, and that's L, and I say lake, do a semicolon, and a fill of 0, because that'll make it black, and then I'm going to do text, do M plus a quote with a space plus L, and let's set it at 20, 20. And if I click that little run button, oops, we have Mirror Lake pop up. Okay, cool. Now, that said, we can actually go into a string and see what is happening on the inside. And I'm going to show this to you guys, is we need to use what's called an index. An index is an integer pointer that looks at a specific position in a data. Uh, in this, each character has a unique index value associated. Um, so if we look, for example, in home, we notice how we start with, it's for long, Home. It starts at 0 and it goes to 3. So your first index is 0. If you think of your random numbers, you remember how random, it goes from 0 to a number. So it's very similar, which is actually on purpose. Okay, so this is different string syntax, and this is some of the things that you can do with string. And you can use this in order to kind of do some tests. Uh, like I said, we can't go in and change stuff, but we can actually go in and we can test different things. We can see if it exists. This is helpful, especially for like lookups. If you're trying to look up a specific person or thing or whatever that has a certain name, you can say, hey, does it start with this? If so, let's go find it. There are more available in the reference category of processing under your help command. So there's things like the length. These are actually L's in case you're wondering. And so these are all things that what it returns with. Same thing with, there's other things that we can use for display. Um, we can look at individual characters and see what they are. So we can look at the character 0 in M. So what's the first letter? What's the first thing in M? Uh, so it's, or in mirror, it's M. What's the fourth thing in M? Well, 0, 1, 2, 3, 4. So that's 0. Now, it's important to remember it's not actually the fourth thing, it's actually the fifth thing. It's the fourth index, but it's one more than that. So, go ahead and we're going to try these examples. See if you can make sure that each thing works and that you can make it work properly. So, just to kind of show you on the programming side of this, and actually I don't need the size anymore because this is all being printed to the console. So I'm going to make a string R. I'm going to say this is Rover. We're going to print, and on a new line, we're going to do R char at 3. And then let's do another one where we print R length. You can kind of guess what that one does for us. And print ln, oh, I meant to make this an ln. R starts with R. Okay, so let's see what this gives us. So the first one, so we did the string Rover. What's the character at index 3, which is really the fourth letter. So it's 1, 2, 3, 4. We're at the E. So it came up with E. Next thing it asks, how long is this? Well, we start at R. 1, 2, 3, 4, 5. It's 5 long. The next one, this is kind of what gets some people. It says it starts with, and it has this lowercase r. And some people like to think, well, it just means R. Does it start with R? And it actually returned false. And the reason why is it looks specifically for a capital R. So if I change this to a capital R, what happens? I get a true. So whenever you're doing those true false statements type things, make sure you're checking and making sure that it works right. Okay. Now, sometimes we want to have multiple lines appear, and like thinking like a paragraph maybe or something like that, or maybe having something stacked. So we use a specific command for this, and we use what's called a /n. So if I go back and if I say, okay, let's say fill 0, and I want to have a string, and let's make it S6, why not, equals mirror, and then we do this n lake. Got a semicolon. Then let's make a text, and we're going to use S6 20 20. Now let's see what happens when I run this. It shows up on a new line. And some people think that it's going to go like /n, and there's actually a way of making it so it can show that in case for some reason you need to have that that slash in there. But in this case, it actually shows, it goes to a new line. There's actually another couple other commands that go with this. So for right now, go ahead and try to create try your own strings and try to manipulate them using that dot syntax. So create a string with something that with a quote you like. Print the string to the console. Can you figure out how long it is in the console? Make a specific character go to the console. Just try making it show up on the screen. Try doing multiple lines. Be creative. Try something new. So take a few minutes, work on that, try that out, see how you can do. Feel free to pause this if you're still working through that and kind of having some fun. Because here's your assignment. Using the warm up and other information that we kind of did, display all letters of the alphabet in one line across the string using text. So on the actual screen, so like on the one that when you push the little play button that pops up, make it show all letters in the alphabet. To do that, use a for loop to increment the ASCII value. You'll just need to adjust so that the letters don't print on top of each other, and that's kind of easy to do. I'd actually almost start with saying try and make it so they print all in one place, and then kind of go from there. Once all the letters are displayed, try changing the color or size of each letter, trying to make them each unique. And be sure to comment on all sections of your code. Once you've completed this, submit the program as a zipped folder. I'm calling it 14.3. Your teacher may have it named as something else. If you forgot how to do this, make sure you check out the zipped folder tutorial that is included with these videos. As always, happy coding.